All right, welcome to another video, the second video today. We're gonna do a quick diversion. Looks like this tutorial isn't that long. You can see the slider bar, I guess, is a little bit thinner uh, or less thin. So I want to learn more about Git. Everything I've learned kind of has been learned on the fly. So I've never really done an official tutorial all the way through. So that's what I'm going to be doing in this video. So this is Introduction to Git and GitHub for Python developers. Might be a little bit too easy for me, too much of an introduction, but at this point, I feel like even in the fundamentals, basics, like there's things missing in my knowledge. So I think this is going to be the perfect tutorial for me. Have you ever worked on a Python project that stopped working after you made a change here or a PEP8 cleanup there, and you weren't quite sure how to get it back? Version control systems help you solve that problem and other related ones. Git is one of the most popular version control systems today. In this tutorial, I'll walk you through what Git is and how to use it for your personal projects and how to use it in conjunction with GitHub to work with other people on larger projects. We'll look at how to create a repo, how to add both new and modified files, and how to navigate through your project's history so you can get back to where your project was working. This article assumes you already have Git installed on your system. If you don't, the excellent Git Pro book has a section on how to do that. So it looks like, so this is a book here. Okay, so if this is too easy for me, I can go through. Uh, I can read a whole book on it if I want. So the book's right here. So let's take the first chapter of that book, and I think I want to add this to my blog space here under wild networking series ideas. So I've got to go sign in, and then I've got to go uh, shoot. Oh, here it is. Okay. Yep. So now, yeah. There you go. Update. What is Git? Git is a distributed version control system, DVCS. Let's down break that down a bit and look at what it means. Version control. A version control system, VCS, is a set of tools that track the history of a set of files. This means that you can tell your VCS, Git in our case, to save the state of your files at any point. Then you may continue to edit the files and store that state as well. Saving the state is similar to creating a backup copy of your working directory. When using Git, we refer to this saving of state as making a commit. When you make a commit in Git, you add a commit message that explains at a high level what changes you made in this commit. Git can show you the history of all of the commits and their commit messages. This provides a useful history of what work you have done and can really help pinpoint when a bug crept into the system. In addition to showing you the log of changes you've made, Git also allows you to compare files between different commits. As I mentioned earlier, Git will also allow you to return any file or all files to an earlier commit with little effort. Distributed version control. Okay, so that's a version control system. What's the distributed part? It's probably easiest to answer that question by starting with a little history. Early version control systems worked by storing all of those commits locally on your hard drive. This collection of commits is called a repository. This solved the I need to get back to where I was problem, but didn't scale well for a team working on the same code base. As larger groups started working and networking became more common, VCSs changed to store the repository on a central server that was shared by many developers. While this solved many problems, it also created new ones, like file locking. Following the lead of a few other products, Git broke with that model. Git does not have a central server that has the definitive version of the repository. All users have a full copy of the repository. This means that getting all of the developers back on the same page can sometimes be tricky, but it also means that developers can work offline most of the time, only connecting to other repositories when they need to share their work, which sounds like a huge advantage. The last paragraph, that last paragraph can seem a little confusing at first because there are a lot of developers who use GitHub as a central repository from which everyone must pull. This is true, but Git doesn't impose this. It's just convenient in some circumstances to have a central place to share the code. The full repository is still stored on all local repos, even when you use GitHub. You know what? Now that I think of it, um, making it so that your developers can work offline actually doesn't seem like a big advantage. It almost seems like a disadvantage because um, if you're designing this system specifically so that developers can work offline, and in doing so, giving up some advantages that you could have if you designed it so that they have to be online, I really don't see that trade-off as being valuable because, first of all, especially nowadays with the pandemic, if you're a developer, like you're probably working remote online and you have to have a working, solid, dependable internet connection where you can be online all the time. Um, Second of all, if you're a developer, um, nowadays, especially, I think back in the day of like when there were like C developers and stuff, they would mostly just be, walking encyclopedias. But nowadays, you're just going to be Googling for stuff like all day, anyways, or like referencing some book you read or some notes you took earlier, chatting with a coworker or something like that. So it's like developing offline, in my experience, just isn't a thing anymore. Like, I would personally not be able to be that effective in the projects I've done if I had to work offline. So having a system that allows me to work offline is just it just doesn't it's like, okay, I can work offline. Well, I can also work on the top of a mountain. Like, why would I do that? I'd have to travel to a mountain, climb a mountain. I'm not going to do that. Like, it just doesn't seem like a good trade-off anymore. I'm actually going to do a few Google searches on that because that's really kind of messing with my mind. In the modern world of development, doesn't make sense at all for Git to allow developers to work offline, question mark. Yeah, I could see this being like really valuable. Like, I could see this being really valuable in an age when internet speeds were slow, were not very good, not very reliable, um, and you know, but nowadays, like everyone's on the internet all the time, all day. So I don't, there's streamers whose job it is to just stay online, like pretty much forever. So like, in real time. So like I don't understand why uh, this is still considered a selling point for Get. Yeah, see here, one of the biggest selling points of Get is that it is decentralized. But yeah, everyone uses it in a centralized manner anyway. And not only that, if the biggest advantage of it being decentralized is that you can work offline, like you don't need to work offline. Like the internet has grown a lot since the 90s. I don't get it. I hope this person gets an answer. Oh, okay. I guess that makes sense. So I guess there's more that so having it be decentralized where everyone has a full copy of the repo and there's not just one copy that everyone works on all at once makes it so that like if you really royally mess something up, um, you didn't alter the one copy of the thing. Like you altered your own copy, and if there's like a merge conflict or like something really nasty, you can just destroy your own copy and then pull back the other copy. So it is the main advantage of having it decentralized where everyone has their own copy of the repo versus a centralized setup where there's only one copy of the repo and everyone logs into that copy and makes changes to that copy. Um, it's the fact that the developers can work offline is just one of the advantages. Another big advantage is that um, uh, because everyone has their own copy, um, it's easier uh, to handle like problems with the code because you can just because you're not modifying the single source of the code that you have, anyways. And it's like, what if I have, you know, if I have written something and then I lose it, it's gone. But what if we all have a copy of what I've written and then I lose my copy? Well, I just take your copy and we're good. So being able to work offline is not the only perk of that decentralized design. Basic usage. Now that we've talked about what Git is in general, let's run through an example and see it in action. We'll start by working with Git just on our local machine. Once we get the hang of it, we'll add GitHub and explain how you can interact with it. Creating a new repo. To work with Git, you first need to tell it who you are. You can set your username with the git config command. Once it is STE up, you will need a repo to work in. Creating a repo is simple. Use the git init command in a directory. Once you have a repo, you can ask Git about it. The git command you'll use most frequently is git status. Yep, so that's what I found. Um, let's start. We're not going to follow along because main reason I'm doing this is because I've been having kind of a tough time here. So I'm hoping to have these problems resolved. So as I'm going through this, I'll continue trying to resolve the problems I've been having based on what I already know and based on what I learned doing this tutorial. So if I do a get status, um, yep, we can see a similar output to what they have. We're also on branch master. Um, yeah, but we've got some more details here that I'm sure will be explained later on. This shows you a couple of bits of information, which branch you're on, master, we'll talk about branches later, and that you have nothing to commit. So I do have things to commit. I have multiple things to commit. Um, this last part means that there are no files in this directory that Git doesn't know about. That's good, as we just created the directory. Adding a new file. Now create a file that Git doesn't know about with your favorite editor. Create the file hello.py, which just has a print statement in it. If you run git status again, you'll see a different result. So, yep, and that shows up in your untracked files. We've got a untracked file here, but it's in my getignore. It'll just be ignored. I'm kind of surprised it's showing up. I wonder if I misspelled it in my getignore. Although I did just do a oh PYC. Aha. Yeah, I did misspell it. So you see I got an extra H here. That's why this is showing up. Okay. Okay, so now we can see that PyCache is gone. I do have another one in here though, but it's the same as up here. I made changes to this file, but I did not stage those to for commit. So let's continue reading here. Now Git sees the new file and tells you that it's untracked. That's just Git's way of saying that the file is not part of the repo and is not under version control. We can fix that by adding the file to Git. Use the git add command to make that happen. So this is a really good explanation for what's happening here. We have a modified, now remember this is version control, so we have different versions of this file. Because we have a GitHub repo, and we can actually go and look into that repo. If I do a ls-a and I do a cd.git, and then I'm pretty sure from here I can do a find dash iname, and then like that. Oh, huh. Well, anyways, I thought I'd be able to see the other versions of the file in here. Maybe you can, maybe you can't, I'm not sure. But if we look at this git status again, um, we see we've got two versions of this. We've got this file showing up here twice. That's because we've got the original version of this file with that typo, PyCache. I had an extra H as a third character. That's what is in this file, which is a part of Git. But then, of course, I have this file again after my modifications, but that just exists here. Um, uh, wait, what? Oh, yeah, it's a hidden file. So it just exists here. It doesn't also exist in the git repo. So we'd have to add that with the command git add. And then we can do get status again. And now we don't have anything. If that's so this is the top level of the git repo here. So everything within this folder is being is also included in our Git version control. So you can have files that are in this folder, but that aren't participating in version control. But Generally, there's really no reason to do that. If you're ever going to do that, you'd want to add that to your getignore file. Um, and so if you ever see anything showing up here, um, that means you either forgot to add it or you forgot to put it in your getignore file. I kind of wish everything would be added like automatically, but I guess this kind of makes more sense because depending on what you have in there, like the virtual environment, if that gets added automatically, there's just a lot of extra files to accidentally include in something. It can get really confusing. So I think it makes sense to have it the way they have it. Now Git knows about hello.py and lists it under changes to be committed. Adding the file to Git moves it into the staging area discussed below and means we can commit it to the repo. Committing changes. When you commit changes, the other thing I'd like to talk about before going into the next section, so I'm going to do code dot, um, and I'll kind of show how I like to use visual code for revision control. So because I did the dot after I ran code, you can see I've got it opened to this present working directory. Now you can see I've got staged changes. Okay, so that's okay. Let me do a git history, or sorry, a uh, git log one line. Oh, what is it? Git log? Your current branch master does not have any commits yet. Oh, okay. So let's do a git commit -m initial commit. Okay, and then we'll do a git log one line. Oh, or let's do a git log. Oh, one line, not online. There we go. So here's our initial commit. Let's do a git push now, or a git push origin master. Okay, here we go. So now it's working. I think the problem we were having before is just some reason the commit didn't go through. I think I needed to like create a branch first. Or it just things were messed up and the commit somehow didn't go through. So things are working now. I kind of feel a little bit dumb now for going through this tutorial, but I mean it's been interesting. I feel like it's good food for thought anyway. It's probably a good a good a good sorry, I got distracted by yeah, I got really distracted. But here, let me just have a glass of water. Okay, so before moving back, I did want to kind of show how I use Git. I kind of gave it away a little bit because if you go to version control, you can see we've got this changes here. So if I open one of these files, let's say app.py, and I say uh, what changed, like that, um, and then I go back. Actually, I've got to do a save too. You can set up Visual Studio to auto save every second, something like that. Yeah, so they make it really easy. You just click that, you get a check mark there, and then every second or so it'll automatically save it. So now we can see we've got this blue circle with a number. The number represents the number of changes. I made one change to the file. So let's make another change. So this is a little bit strange. You'd think there would be more than one change, but nope, there's still just one change. Uh, if I were to commit this change, I guess if I want to make two changes show up, I'll have to modify another file. So this file, that should, yeah, so now it's incremented to two. This is the number of files that you changed. So I changed two files. In those files, I have two changes in the app.py file. And then the changes are here. So we can see, yep, one of two changes. And it'll show you and then say, oh, no, I actually didn't want to do that. I can revert it there. See this one. Okay, that's good. Oops, I actually didn't want to do that either. So, and then you can move to the next change. You can take it change by change. You can say, oh yeah, this was a good one. I want to keep this change, stage that change right away. So I definitely recommend um, using an IDE like Visual Studio Code is the one I use, but there's other ones out there too. I just like Visual Studio Code the best. Um, yep, and now here's another change. So we'll leave that change up, and now we'll go over here, and now we can see it shows up here, and you get this nice difference, working tree tab showing up where you can see the differences between the changes and the other ones. So let's go and let's keep that change. So we're going to go back to the original file here, and we can see nice and easy. It's got an M there, and then even here we've got this blue part that shows. Sure enough, there's a change right here. So we're going to stage that change by using the plus sign here. Okay, so now we've still got a change showing up, but now it moved from this changes here to this staged changes here. So it's kind of unnecessary, but this change stages shows you what will actually get pushed next time you do a git push. So you don't have to push all of your changes. Let's say you're working on something complex, you find something stupid, um, just a grammatical thing or whatever. You can stage that change, push it, and then work on more important things. So that's kind of the way it's meant to be. You're constantly committing, pushing little tiny chunks with basically your thought. You build it up piece by piece. You don't just do it all in one sweep and then at the end kind of summarize what you did. That's not how it's meant to go. Okay, so you can see I've got this showing up in my stage. I can do get reset head requirements.txt, and now it moves back to changes. There it is in changes. So I think reverting is probably easier if it's not in the changes. Let's try that again. So we're going to do get add, and we'll move this to change stages. And yeah, sure enough. So here we can see reverting the change. We don't even have the option to do that. If you want to easily revert changes, you've got to make sure that your files aren't staged. But Visual Studio makes that really easy. You just click on stage, then you go here, and now you can click revert, discard changes, and now we no longer have any changes that are either staged or unstaged. All right, so committing changes. When you commit changes, you are telling Git to make a snapshot of this state in the repo. Do that now by using the git commit command. The -m option tells Git to use the commit message that follows. If you don't use -m, Git will bring up an editor for you to create the commit message. In general, you want to commit your commit messages to reflect what has changed in the commit. Okay, So yeah, and the better you can make your commit messages, the better it is for people. So like for other people who come back and look at it. So like this, I would say, is not a very good commit message because you can just look at the diff, like what actually was committed, and you'll see, yeah, it created a file. So this is kind of, Captain Obvious commit message. A much better commit message here would be like uh, including the link to the tutorial or the documentation that told you you were creating this file, and saying like step one of documentation complete, and then like the pipe key, and then a link to the documentation. If you're on the job and you're using a ticketing system, always put the tickets in your commit messages, and you can even do some kind of automation to uh, tie that your commit messages into like reporting tools to give like automatic updates on progress and stuff. So this is unfortunately a very bad example of how to write a commit message, but I don't think it's that hard to write good commit messages. It's just one of those things where if you never build the habit to do it, you're just going to have a really hard time catching on to it. But if you do build the habit, and you kind of know how to uh, give a good commit message, it doesn't like these are like the kind of like soft skills of programming where like you don't have to be a genius, brilliant programmer who was programming since you were two and who hacked the some major government in the world and did this, that, or the other thing. Uh, if that person doesn't have good commit history messages, nobody knows what they're doing. They can't work with anyone else. From what I've seen, that person is not nearly as valuable as somebody who uh, has it in the documentation, links it properly, um, uh, calls out what they're doing, provides references, uh, that sort of thing. It's really, in the end, it really is. To be perfectly honest, in my opinion, it is all about whether it works or not in the end. But along the way, you're much likely to get things to work if you have those kind of soft skills and good habits built, especially if you're doing something working in a team. You can see the commit command returned a bunch of information, most of which isn't that useful, but it does tell you that only one file changed, which makes sense as we added one file. It also tells you the SHA of the commit. We'll have an aside about SHA, which stands for Secure Hashing Algorithm, a bit later. Running the get status command again shows that we have a clean working directory, meaning that all changes are committed to Git. At this point, we need to stop our tutorial and have a quick chat about the staging area. Aside, the staging area. Unlike many version control systems, Git has a staging area, often referred to as the index. The staging area is how Git keeps track of the changes you want to be in your next commit. When we ran git add above, we told Git that we wanted to move the new file hello.py to the staging area. This change was reflected in Git status. The file went from the untracked section to the to be committed section of the output. Note that the staging area reflects the exact contents of the file when you ran git add. If you modify it again, the file will appear both in the staged and unstaged portions of the status output. At any point of working with a file in Git, assuming it's already been committed once, there can be 3 versions of the file you can work with. The version on your hard drive that you are editing, a different version that Git has stored in your staging area, the latest version checked into the repo. All three of these can be different versions of the file. Moving changes to the staging area and then committing them brings all of these versions back into sync. When I started with Git, I found the staging area a little confusing and a bit annoying. Me too, and I'm still kind of seeing it that way, so hopefully this will help me out here. It seemed to add extra steps to the process without adding any benefits. When you're learning when you're first learning Git, that's actually true. After a while, there will be situations when you come to really appreciate having that functionality. Unfortunately, those situations are beyond the scope of this tutorial. Yeah, so that's where I'm at now. Everything I've done with Git, that's kind of been a unnecessary burden. So I'm kind of curious what those situations are. I don't really have a need to go beyond the scope of this tutorial right now, especially since this is just a diversion off from a larger goal. If you're interested in more detailed info about the staging area, I can recommend this blog post. And I am interested in this. It looks like it is pretty short, but let's move on to the and maybe come back to that if I have time. I might need to take a break here soon. We're at the past a half hour mark. Um, I'm gonna take a break right now. I'll be back soon. All right, I'm back after a pretty substantial hiatus there. I've got about 36 minutes already on video, so I definitely want to close this out. I'm on the getignore section, so we'll just start where I left off. The status command is very handy, and you'll find yourself using it often, but sometimes you'll find that there are a bunch of files that show up in the untracked section that you want to get to just not see. That's where the .getignore file comes in. Let's walk through an example. Create a new Python file in the same directory called myname.py. So we're going to skip all the examples. This is a bit too basic for me. I could use a more advanced tutorial, but I'm just going to go through this for the sake of the channel. I think this could be useful for other people to see. Especially people who are really strong in network engineering and never seen anything like this. You can use a Git repo and like a GitHub account. Now, of course, you wouldn't want to you'd have to be careful about making like passwords public and stuff like that. But for like configs and stuff, backing up configs in a Git repo can let you see more easily the changes um, in your config. So if you're used to Juniper's and you're used to the command showpipe compare, you can do something similar uh, using revision control on devices that don't have that kind of compare capability baked in. Then modify your hello.py to include my name and call its function. Okay, so here we go. When you import a local module, Python will compile it to bytecode for you and leave that file on your file system. In Python 2, it will leave a file called myname.pyc, but we'll assume you're running Python 3. In that case, it will create a dunder pycache, and dunder means the underscores at the beginning and the end, directory, and store a pyc file there. That is what's shown below. Now, if you run git status, you'll see that directory in the untracked section. Also note that your new myname.py file is untracked, while the changes you made to hello.py are in a new section called changes not staged for commit. This just means that those changes have not yet been added to the staging area. Let's try it out. Okay, so we already went through that. Before we move on to the getignore file, let's clean up the mess we've made a bit first. We'll add the myname.py and hello.py files, just like we did earlier. Let's commit those changes and finish our cleanup. Now when we run status, all we see is that dunder pycache directory. To get all dunder pycache directories and their contents to be ignored, we're going to add a .ignore file to our repo. This is as simple as it sounds. Edit the file. Remember the dot in front of the name in your favorite editor. Now when we run git status, we no longer see the dunder pycache directory. We do, however, see the new .getignore. And this is just a part of this sentence. It's not a part of what we see in the output. Down here we see the output. Take a look. This exclamation point here. That file is just a regular text file and can be added to your repo like any other file. Do that now. Another common entry in the .getignore file is the directory you store your virtual environments in. You can learn more about virtual envs here, but the virtual virtual env directory is usually called env or venv. You can add these to your .getignore file. If these files or directories are present, they will be ignored. If not, then nothing will happen. It's also possible to have a global .getignore file stored in your home directory. This is very handy if your editor likes to leave temporary or backup files in the local directory. Here's an example of a simple Python .getignore file. For a more complete example, look here, or if you want to build your own, gethelp getignore provides all the details you'll need. Oh, okay, so that's a really good tip there. Let's run that command to get used to that. Oops, it looks like my it looks like my lab for some reason shut itself down. So we're gonna boot it right back up, get in there, and then play around with this help. We'll also do a gethelp branch and a gethelp merge, gethelp pull, gethelp push. Really get a sense for this help command. What not to add to a Git repo. When you first start working with any version control tool, especially Git, you might be tempted to put everything into the repo. This is generally a mistake. There are limitations to Git as well as security concerns that force you to limit which types of information you can add to the repo. So right off the top, so here's my question to you. What is one thing you would not want to put in your repo? 3, 2, 1. Okay, so for me, the number one thing I wouldn't want to have in my Git repo is confidential information like passwords. But let's see what this tutorial says. Let's start with the basic rule of thumb about all version control systems. Only put source files into version control, never generated files. In this context, a source file is any file you create, usually by typing in an editor. A generated file is something that the computer creates, usually by processing a source file. For example, hello.py is a source file, while hello.pyc would be a generated file. There are two reasons for not including generated files in the repo. The first is that doing so is a waste of time and space. The generated files can be recreated at any time and may need to be created in a different form. If someone is using Jython or IronPython while you're using the Cython interpreter, the .pyc files might be quite different. Committing one particular flavor of files can cause conflict. The second reason for not storing generated files is that these files are frequently larger than the original source files. Putting them in the repo means that everyone now needs to download and store those generated files, even if they're not using them. The second point, this second point leads to another general rule about Git repos. Commit binary files with caution and strongly avoid committing large files. This rule has a lot to do with how Git works. Git does not store a full copy of each version of each file you commit. Rather, it uses a complicated algorithm based on the differences between subsequent versions of a file to greatly reduce the amount of storage it needs. Binary files like JPEGs or MP3 files don't really have good diff tools, so Git will frequently just need to store the entire file each time it is committed. When you are working with Git, especially when you are working with GitHub, never put confidential information into a repo, especially one you might share publicly. This is so important that I'm going to say it again and put it in its own special box highlighted in blue. Caution, never put confidential information into a public repository on GitHub. Passwords, API keys, and similar items should not be committed to a repo. Someone will find them eventually. But that's not the only thing not to commit. The other big thing not to commit is anything that your uh, code that you're committing will generate, because you want to make sure that when somebody pulls it down, um, they're going to have the files that were generated by um, your source files in your code, and they're not just gonna say, oh well, look, I already have the output, I don't even have to run it, and then they use these files that aren't relevant because they never even ran your program. Don't even give them the chance to mess up, and just don't include those files at all, so that they only have access to the output of the program after they run it. They can't just use the output that was generated by somebody else at some earlier time and then upload it to the repo. So make sure every output of every output file that generates as a result of your source files is ignored and not added to where you're storing your code. Aside, what is a SHA? When Git stores things, files, directories, commits, etc. in your repo, it stores them in a complicated way involving a hash function. We don't need to go into the details here, but a hash function takes a thing and produces a unique ID for that thing that is much shorter, 20 bytes in our case. This ID is called a SHA in Git. It is not guaranteed to be unique, but for most practical applications it is. Git uses its hash algorithm to index everything in your repo. Each file has a SHA that reflects the contents of that file. Each directory in turn is hashed. If a file in that directory changes, then the SHA of the directory changes too. Each commit contains the SHA of the top level directory in your repo along with some other info. That's how a single 20-byte number describes the entire state of your repo. Oh, okay. I guess I'm not sure. Oh, okay. So we want to go into more detail. We can read that to figure out how we get that. I'm not that interested in the details of that. Just knowing that there is a hash and you can use that to reference a commit is all I really need to know for now. You might notice that sometimes Git uses the full 20 character value to show you a SHA. Sometimes it shows you a shorter version, and it looks like the shorter version only has the front part. Usually it will show you the full string of characters, but you don't always have to use it. The rule for Git is that you only have to give enough characters to ensure that the SHA is unique in your repo. Generally, 7 characters is more than enough. Each time you commit changes to the repo, Git creates a new SHA that describes the state. We'll look at how SHAs are useful in the next section. So another thing I really, really like about this tutorial is things that are outside of the scope of the tutorials, really deep in the weeds. They give to you, but they put them in links, and they say, like for example, here, um, uh, oh, where was it? But learning how, yeah, right here. So with some other info. So if you want to learn every little detail about the link, you can just click this other info and you can go and learn about that. Likewise, if there's something they expect you to know, um, like Python virtual environments, just the basic of that, they'll link you to that too. So really, really good tutorial here. I can't recommend it highly enough. All right, so next section is going to be git log. I got to take a quick break again. I'll be back soon. Okay, welcome back. I'm going to make as much progress on this as I can. Git log, another very frequently used git command is git log. Git log shows you the history of the commits that you have made up to this point. As you can see in the listing above, all of the commit messages are shown for our repo in order. The start of each commit is marked with the word commit, followed by the SHA of that commit. .log or get log gives you the history of each of the SHAs. So let's take a look at get log. And there was a command I wanted to do. Oh, right, I wanted to do the help commands. So we've got a number of commands here to enter in. All right, next part is going back in time, checking out a particular version of your code. Because Git remembers each commit you've made with its SHA, you can tell Git to go to any of those commits and view the repo as it existed then. The diagram below shows what Git thinks is in our repo. Okay, so we've got our, so this head I think here looks at is which one you're looking at. Don't worry about what master and head mean in the diagram. We'll explain those in just a bit. To change where we are in our history, we will use the git checkout command to tell Git which SHA we want to look at. Let's try that. Okay, so let's go to our environment here. We're going to open the terminal, go into our real Python and do code dot. And then we'll try some of these things. While that's loading up, let's go back to our terminal. And we'll do git help, and then we'll do merge. Perfect. So we've got some good documentation about that. We'll do git help pull. Yep, good documentation there. And then git help remote. So you can see just right in the CLI without having to go on the internet or anything like that. You've got some pretty solid documentation built in if you use these git help commands. Okay, so the next thing we're going to do is close this terminal, come over here, then let's go here and we'll say version 1. Okay, so now if I go over to my version control, we see we have some changes here. Let's click on that. So I added line 12 here. We can see line 12 was not existing before, so I got a minus sign in red, but now we've got a plus sign in green because this is the change I made. I added it new, and in addition to that, I added some more text here. So let's go ahead and commit that change. So we're going to first stage the change. Okay, and now that the change is staged, we can still get that workspace back. Um, let's unstage the change and see if there's any differences. Okay, so it looks like whether it's staged or unstaged, you can still see everything here as you would see it. There's no changes. Um, so yeah, let's go ahead and commit that. So uh, we're gonna do up here do a this hit this check mark so that we're doing commit, and now we're gonna give it a message. We're gonna say uh, experimenting with um, checkout. Okay, so now we hit enter. There we go, and we got our commit message. We committed everything, and we did it all uh, right there, just with that. And now we can push our changes at the end. Um, yeah, we're gonna publish the branch. Uh, no, we don't want to periodically run that. Okay, now we've got our everything all set. We don't even need this final part really that much anymore. So if I take a look at my, oh, actually we kind of do need it a little bit. Let's see if we can look at our history just using this here. Okay, I don't see how to see any logging. Maybe in the Git output. No, I still don't see anything there. Um, all right, well that's kind of too bad that there's not an easy way to see your your logs or your histories from there. Yeah, that's really kind of too bad. But you've always got the CLI. Um, so oh, I guess we've got this check out too. Let's see. Okay, so we've got yeah. See, I'm not too happy with that. I like just doing get log dash dash one line, and now you can see it's all clearly listed there. This is the first commit we made, and then this is the latest we just made. So the newest on top is how it works. So let's make one more change just to make things super extra clear. Okay, we're going to change this to version 2. Take a look at what we did. We changed the 1 to a 2. So now we'll stage the changes, and then now that they're staged, we'll commit the changes. And we got to give it a message. Uh, See, now I don't really like this as much because if you're doing so get status, you can see we've got the same thing here. But what I can do is I can do a get status or a get log one line, and then I can really and it's got to be one line, not online, and I can really easily see my other messages. So here, if I do a get commit dash m, it's my previous message is just right there, uh, ready to go. So you can copy and paste from your previous messages if you use the CLI. You can't really do that as easily if you're just using the GUI. So there's advantages to both. I prefer the CLI, but I'm definitely, I think, gonna start getting used to using the GUI more than I have been. All right, so Moving on, uh, to change where we are in our history, we will use the get checkout command to tell Git which SHA we want to look at. Let's try that. Okay, so we're gonna try that. So if we do a get checkout, we should see uh, things change. So, uh, and okay, let's do an escape. Perfect. Um, so let's take a look at our file here. So requirements.txt, we can see we're on version 2. Let's do a get one line, get log one line. So here's one line with an E instead of online. So we've got 3 commits here. Let's see what happens if we do a get checkout on our second commit. Okay, so now we can see this 2 changed to a 1. Let's do that again. So get log one line and then get checkout. But now let's check out using the hash for our initial commit. Oops, so it looks like I took the wrong hash, so we're not going to have any changes there. Okay, so now that I've got the correct hash, we can see it goes back to the original form. And not only that, we don't have any changes actually because we're checked out and looking at a position uh, that was earlier. So all the things that came later um, are kept in our history, but they're not registered as changes because we didn't make any changes. So what we can do now that we're back looking at an early commit, we can make different kinds of changes, and then we can compare these different kind of changes to the other changes. Kind of if you think of a Y, like a fork, like we can branch it off in different directions and basically have the software compete against itself. So let's go back to the latest commit. And I won't forget the E there. And we'll do a get all, but you can see it's a little bit tricky because it looks like we lost those latest ones in the log. So that's definitely no good. Um, I kind of wish that didn't happen. Um, yeah, that's too bad. Let's try just doing a get checkout. Oh, okay. There we go. So so unfortunately, the kind of bad news is that you've got to save somewhere the other commits. Maybe there's a switch or something, but you can see the version 2 is back, and not only that, you can see we've now got all of our uh, logs showing up. So that's kind of an unforeseen consequence of jumping around here. You lose the hashes in this file. Maybe there's another way to access them, but you've got to be prepared for that. I wonder if I do a change into a get and I do index or cat index. Oh, no, that's a compiled file. When it looks all jumbly like that, it means the file is compiled, so you're not looking at the actual source code. Okay, so here it looks like we've got the hashes. So let me try uh, doing a PW. I'm going to do a PWD here. Perfect. And then what we're going to do is copy this we're going to go back and check out. So we'll go back to our main area, and then we'll do a get. We'll do a history pipe, and I can't type. Checkout, and then we'll do 13. Perfect. So we can see we're back to our initial commit. We don't have this modification here anymore. Oh, I've got a, and then we'll change directory. Cat master. Aha! So this is a way you can determine which. So even though if I do a get log one line, which I might need to be positioned at a different. Nope. So even though it's missing from here, we can go back and look at what the hashes are by looking in this directory here. So let's move back into the one we want to be in. And you can see we can be in any hierarchy as long as we are within the repo. That is totally fine. Oh, actually, never mind. It must run in a work tree. So we do have to be at a specific part of the repo. But it's really easy to get there. Aha, so now, oops, so it looks like I went to the initial commit. Okay, so it looks like it was in a different order than usual. Yeah, so it's listed in with the earliest commit listed first. If you do a get log, the earliest commit is listed last. So this is the actual hash that we needed. All right, and now we've got our change back, and it's the second change that we made. Okay, so there's a lot of information here that's confusing. Let's start by defining some of those terms. Let's start with head. Head is Git's name for whatever SHA you happen to be looking at any time. It does not mean what is on your file system or what is in your staging area. It means what Git thinks you have checked out. So if you've edited a file, the version on your file system is different than the version in head. Yes, head is in all caps. Next, we have a branch. So branches and heads are two very different things. Heads, I think I have a really good understanding of. A head is the basically, if you were to think of it as the letter Y, and let me make this really clear here. So so I'm going to draw this drawing here. Um, so this right here, see this, how you can choose to go either to the left or to the right. Now that is basically a head. So and then you can make all of these changes. So now that's a little bit confusing, but let me make it really simple. So if I open up VNC, I open up my here, and then I do get log one line. So make it really, really simple. These string of characters here, these are all heads. So if you go to one of these heads, you can make changes so that you have another head that is also one change since this head, and then you can compare those head to head and see which change is better. Next, we have branch. The easiest way to think about a branch is that it is a label on a SHA. It has a few other properties that are useful, but for now, think of a branch as a SHA label. Note, those of you who have worked with other version control systems, I'm looking at you Subversion, have a very different idea of what a branch is. Git treats branches differently, and that is a good thing. When we put all this information together, we see that detached head simply means that your head is pointing to a SHA that does not have a branch or label associated with it. Git very nicely tells you how to fix that situation. There will be times when you will want to fix it, and there will be times when you can work in that detached head state just fine. Let's get back to our demo. If you look at the state of the system now, you can see that the .getignore file is no longer present. We went back to the state of the system before we made those changes. Below is the diagram of our repo at this state. Note how the head and master pointers are pointing at different SHAs. All right, now how do we get back to where we were? There are two ways, one of which you should know already. Yep, so did that demonstration. This will take you back to the SHA where you were at when you started moving around. Note one odd thing, at least in my version of Git, is that it still gives you a detached head warning, even though you're back to the SHA associated with a branch. Yeah, Git is like buggy and weird. It's weird. Um, the other way of getting back is more common. Check out the branch you are on. Git always starts you off with a branch called master. We'll learn how to make other branches later, but for now we'll stick with master. To get back to where you were, you can simply do git checkout master. This will return you to the latest SHA committed to the master branch, which in our case has the commit message created.getignore. To put it another way, git checkout master tells Git to make head point to the SHA marked by the label or branch master. Note that there are several methods for specifying a specific commit, and the SHA is probably the easiest to understand. The other the other methods use different symbols and names to specify how to get to a specific commit from a known place, like head. I won't be going into these details in this tutorial, but if you'd like more details, you can find them here. And this is probably that same, yep, this is that same book we were looking at before. It's just a specific area of the book. All right, so that's going to be it for this video. When we come back, we'll be learning about Git branching basics. So thanks for watching and see you in the next one.